kind of bridge. Okay, let me share my screen. Hope it is visible to you.
Sir.
Yeah, let me quickly revise the concepts that we discussed in our last class. And so the class was about, what is machine learning, how to practically implement it, what are the different libraries that may help you in in creating a machine learning model. And we tested a couple of machine learning algorithms on our data set. That was iris data set that contained 150 samples, and those samples were belonging to three categories of iris flower. And the data set was available in the form of a CSV file. So this iris.csv contains the data set, and it contains basically 5 columns. There are 4 feature columns, and there was one class level, or you know uh, that we need to train the model on. So we imported the packages like this. We imported this pandas package. We imported this numpy package, and then for visualization we imported these 2 packages, matplotlib and seaboard. And then for reading data from our drive, we just mounted our drive. And for mounting, these were the 2 lines. So we imported this Colab package from Google, and drive.mount function. So once we executed it, it established connection with our drive, and it was able to read and write data from this particular folder. And for reading data, we have this function called as read underscore CSV. And so for allowing drive to read data from disk, I need to provide it permissions. So it is mounted, and these are the 5 column names. So there was sapple length, sapple width, petal length, petal width, and class. And it will take a little time to mount it at the first time. So once you execute these, different columns, then you'll see that this is executing. And then we saw some of the samples from the data set. So for doing that, there is a function called as head. So by default, it prints 5 values from your data, and it is printing them in this way. But if the number of columns in your data set is very large, so you can even show it in the form of a transpose matrix. So you can call transpose function on it. And once it is done, then it will show these 5 samples, but your column names, kind of inverted to uh, these rows. So if you are having many columns and you want to just see 4 5 samples from your data, so in that case, it will not be able to display in the entire column list on the screen. So a technique is to transpose the matrix so that you can read it conveniently. And in the same way, you can display some of the data from the bottom of your data set. So for that, there is a function called as tail. If you want to randomly get some samples from your data, then there is a function called as tail. So randomly it has picked up row number 96, 94, and 125 to show you the samples. And if you want to test something and you want to keep these samples same, like in this case, if you execute it one more time, so you will get a different list of samples. So this time it has picked up 24, 43, and 28 row numbers. And if you keep on executing it, you will get different samples. But if you want to keep these samples fixed, so you can tie it up with some random state. There is an attribute called as random state, and if you seed it to some integer value, and if you execute it, so you will get the same set of random numbers every time. And now it is fixed to this particular number. So if you are seeding it with random with the variable 12, then you'll get this these samples from row number 40, 146, and 38. So every time you execute it, you'll get the same thing. But if you seed it to some other number, suppose 123, so you will get different set of values. But it is just for the sake of reproducibility. And the reproducibility means that you want to suppose reproduce your data. Suppose you have trained some machine learning algorithm and your accuracy is 93, and you want to demonstrate your model that your model actually delivers an accuracy of 93. But since there is some sort of uncertainty in machine learning, because you are doing training and test split, so your data may be different. And next time when you are executing the same code, you'll get a different accuracy. So how to make your results reproducible? So for that, we have this attribute called as random state, so that we can kind of generate same data every time, so that your results may be reproducible, and you may get the same set of results. So this is kind of very important thing to consider, that what this random state does. We'll be talking this random state once again when we'll be discussing about our another method, which is train test split. And yeah, so this is showing you some of the samples that you are picking from your data randomly. But if you want to make them pseudo random, it means you want to get the same samples every time, so you may attach it with some uh, kind of seed that will generate the random numbers. So this is the seeding, and you'll get the same random numbers uh, every time. And info function is very important. It will give you some snapshot about your data, like what are the different columns, how many not null values you have, and what is the count of not null values, what are the data type of each of the columns. So there are 5 attributes in our data set, and these are sepal length, sepal width, petal length, petal width, and the last one is class. So it is telling me that there are 150 not null values. So none of the values are missing, but practically when you deal with real life data, then there may be some values which are missing, and you are supposed to deal with those missing values. So how you can deal with the missing values in the data set? Yes, any idea on that? How can we deal with missing values in the data set?
So we can either delete it or fill it with whatever is the mean or average of the data.
Yes, yes, absolutely. So depending on what is the data type of our column where the values are missing, so we have different strategies to deal with missing values. The simplest being that we delete the row that contains missing values, or if there are many missing values in a particular column, so we may delete the entire column as well. And there are functions for doing that. Another strategy is to fill a particular column with with either mean, median, or mode of the data, depending on what type of data we are dealing with. So do you understand what these terms mean, mode, and median uh, have
Yes,
their
yes, yes.
meanings? Yes, who will tell me the difference between mean, mode, and median? Yes, these are just the measurements of some statistics about your data. So mean is just the average of certain values. Mode is the most frequent value, and it is generally helpful when you are dealing with categorical or some textual data. In that case, you will take into account that which is the most frequent value that you are having in your data. And median is when you sort your data in some order, and it is just the middle number or the middle element that you have after sorting your data. So you can use mean, mode, and median for filling up the missing values, and it depends on what type of data you are dealing with, what is the nature of column. But this is certainly very important task that you need to perform, and it is the part of data kind of wrangling or data cleaning. And then you can look at some of the attributes about your data, some of the statistical information about your data. So there is a function called as describe. So by default it takes into account the numerical values, and it presents a mean, standard deviation, some minimum value, some maximum value. And you can look at these terms, and these terms are very useful to detect sometimes the outliers. Sometimes you may be interested in looking at the distribution of the data, uh, and this is very useful before you kind of train some model on your data. So we are describing our entire data set, and it will automatically pick up the values that have numerical data. And if you are interested in describing a particular column from your data set, like I'm interested in understanding like how this sample length is distributed, what are, and I want to just create one distribution plot around it, so I can do it. And if I'm interested in just describing or getting some details about this particular column only, so I can also do that. So df, and for referring a particular column, I can just script it with the name of column. So sample length for this time, and I want to just see the description of this particular data set, this particular column. So here you can set that you are getting this information about this particular column. And let's try calling it with our class label. Yeah, so by default, it just takes into account the numerical values. When you were calling describe on this entire data frame, then it excluded the numerical, the categorical value. So the column class was containing categorical values because they contain the names of the classes. But here you can see that you know all these unique. So the count is 50, and there are 3 classes, and it has picked up this iris setosa because these are equisampled. All these 3 classes are having equal sample, which is 50 each. So it has picked up uh, you know uh, this particular class iris setosa. But if you have unevenly distributed data set, and you want to get this information that which particular value is most frequent in your data set, and you can call this describe function on on categorical values as well. And suppose if you want to kind of print distribution about this sample length, so we have very kind of very powerful visualization libraries. Matplotlib and Seaborn are very extensively used. So Matplotlib is a kind of very basic library upon which the Seaborn library is built up, and you have many sophisticated functions that you can call. Suppose if you want to call a function called as dist plot, so it will draw a distribution plot for your data set, and you want to see the distribution plot of sample length. So it will show you the distribution plot of your sample length, that how uh, how these values are kind of distributed. So here you can see that most of the values, the range of the values lie between this 5 and 6, and some of the most high values are near to 4 and 5, and this. So here you can see that how distribution plot is there. Even you can compare two values together, and you can plot multiple distribution plots. Like if you want to compare sample length and petal length, so these are two distributions, sample length and petal length, and these are the distributions. So the visualizations may give you some sort of idea about how your data set is. And there are different visualization tools available. In the last class, I also discussed you to refer uh, the websites of this Seaborn and Matplotlib. And Seaborn is a very, very powerful library, and you may refer to its website. You can see that what type of visualizations you can have, and so you can refer to it. You may find out some of the examples from example gallery, how to this is IM plot, this is scatter plot, this is line plot, this is distribution plot, this is relational plot that shows you the relationships between two variables. This is cat plot, box plot, violin plot, rel plot. So there are many types of visualization plots that you can explore. And another thing is to understand the relationships among variables, like how two variables are related. Is there any sort of correlation? If you're increasing one variable, so is the other variable increasing or decreasing? So there may be some sort of relationships among variables, and you can kind of find out those relationships with the help of various statistical techniques. Like you can find out the correlation among different techniques, and so there is a function for, and let's find out that how particular variables are correlated. Let's call it on TF. Different relationships, that how the variable so here you can see sample length is very much correlated with sample length. It is perfect linear correlation. If we talk about sample length and sample width, so it is almost negatively correlated, but there is very weak correlation. So higher the value, it should be between 0 and 1. It can be even negative. So, kind of higher or lesser the value it is, the more correlation is there. So sepal length and sepal width, they are inversely correlated. If you increase the sepal length, the sepal width will, decrease. It is like that. And sepal length and petal width are strongly and positively correlated. So if the sepal length is more, then there will be more petal length. And again, this correlation is there between sepal length and petal width. And this is again positively correlated. And you can depict it. It's a more sophisticated, representation. And you can specify here a method. So there are different methods to find out the correlations. So one is Pearson. So it will by default, give you the Pearson correlation. And yeah, it's giving you that. There are other methods as well. Like if you choose a method called as Kendall, then it will give you, there is another method by which you can find out the similarity or the correlation, but this time you are getting the same, values, but the values will be different because different method has been used. And you can represent it some visually appealing, form. So there is a uh, visual representation called as heat map by which you can represent these values. So there is a function in Seaborn, and that is heat map. Let's call that sm dot heat map. We just need to pass these values for the better visualization. Yeah. And we want to annotate it. Right. So if you just execute it this way, then you'll see this beautiful representation, and it is represented it, kind of more visually appealing way. And it has been represented with this, scale, and with there is more positive correlation, then you can see that this shade of, you know, color is there like 0.18. So there is, you know, wherever this is more correlated, then the shade of brown will be lighter, and brown means more correlation, and this, black means there is less correlation, and again this, kind of violet shade. So this is something, a visualization that you can use combined with your analytics to convey some meaningful information. And why do we need correlation? Because when the number of features are very large, so maybe you would discard some of the features, or you will be doing dimensionality reduction, or maybe eliminating some of the features. So there, this correlation, representation, or these correlation values may help you to reduce the dimensionality. The features which are very much correlated, so you would just like to keep one of those features only, because if there is sepal length and there is, petal length, and you are asked to keep only one. So you can see that sepal length and petal length are very much correlated. So even if you keep one, uh, it won't make much difference in overall accuracy. So this is something, that you can do with data set. Yeah. And we use these some of the plots. So you refer to this particular, beautiful gallery, and try to learn that what each of these graphs mean and how to draw them. So there are simple functions for doing that, like we just discussed heat map. So this is how heat map is represented. Even you can use joint grid. You can use this violin plot. So there are many, different plots, and this seaborn is very, very, extensively used even in the industry. It is very much in demand. Then we talked about some of the basic concepts of machine learning. And as we understand that machine learning can be roughly divided into two, types, supervised and unsupervised. When we talk about supervised learning, then we have some labeled data and we train our models based on that labeled data. So can you tell me some of the varieties of supervised learning? What are the subtypes of supervised learning? Yes. Do you recall?
Yes, sir.
Yes.
Yes, sir.
Yes. What are the subtypes of supervised learning? Yes. So supervised learning can be either classification or it may be regression. What is the difference between classification and regression? Yes. Is there any difference, or these are two that are equal, meaning? Okay. So when we talk about regression, so regression, in regression you get some continuous value, some real value, and in classification you get discrete values. Suppose you want to train a classifier that will, kind of give you whether a particular uh, plant of iris belongs to one of these three categories. So class labels are fixed. We have only three labels and you need to classify your data among those categories only. So when you have some discrete labels and you have some labeled data, then it is called classification. And when you have some continuous data, means you can get any real value in a given range. So it is called regression. Suppose the price of a stock at any given day. So it may be a regression problem because the price may be anything. It may be a real value. Maybe today it is 175.9 and tomorrow it is 182.7. So it may be any value. And when you have some continuous, outcome, so it is called a regression problem. But both are supervised learning and both require labeled data and both are machine learning techniques, and there are many algorithms around regression and classification. So today we are going to talk about again the classification problem, and classification problems can be of different varieties. The simplest being the binary classification, where you just have two classes. Suppose you are training a system to detect the presence or absence of a disease. So it will be a binary classification problem. Suppose you have chest X-rays, and you just want to establish whether an X-ray image is having COVID or not. So it will be just a classification problem. Either the disease will be there or it will not be there. So when you just have to, answer in yes or no, then it is binary classification. But when there are multiple classes, more than two classes, then it becomes a multi-class classification problem. So there are multiple diseases, like there is, viral pneumonia, there is bacterial pneumonia, there is COVID, and the absence of any of these diseases. So there are these 3-4 classes, and you want to train a system. So in that case, classifier will be multi-class classification. And another category in multi-class classification is multi-label classification. Suppose you want to label a particular data, but there may be multiple labels, like you're having chest, pneumonia as you're having some other disease. So it will label that there are 70% chances that you have this viral pneumonia, and there are uh, there are 30% chances that the person is also having TB. So it will be a problem of multi-class classification, multi-level, multi-class classification, right? And there are many different algorithms depending on the kind of data that you're dealing with. If you're dealing with images, so convolutional neural networks are very good classification strategy. If you're working with the speech data, then HMM may be a good strategy to deal with that data. If you are having some time series data and you want to do forecast on that, so there will be different techniques for that. Like if there is some sort of sequence in your data, then you may use recurrent neural network, RNN, you may use LST, and you may use GRU. So there are different techniques based on the nature of the data that you're dealing with. And and in general, the classification techniques are some of the feature-based techniques are there, and some techniques are called end-to-end learning techniques. Like if you talk about some of the feature-based technique where your data needs to be represented in some numerical representation, intermediate numerical representation. So some of the techniques that work on features are decision trees, nearest neighbors, LDA, logistic regression, random forest, XGBoost. So you can kind of work on data where you have numerical representations, like you want to work on textual data on natural language processing. Even in that case, if your data is in the textual format, it needs to be converted into some numerical representation. There are various libraries to do that. Like you can use Word2Vector, or you can use BERT, you can use Groovy. So there are different libraries for doing that, but ultimately your whatever data you are dealing with, that needs to be represented some numerical representation. And we may have some intermediate steps called as feature extraction or feature representation to make that task easy. So for traditional machine learning algorithms, there is a very popular library called as scikit-learn, and comes in the form of sklearn package, and it has many important functions or packages that can make your machine learning, training a machine learning task very easy. So we have imported sklearn, and for training in TestScript, there is a sub package called as model selection. We have imported this package from model selection. We imported this particular function from this particular sub package. And for decision tree classifier, we imported it from sklearn.tree. Logistic classifier, we imported from linear_model. Support vector machine, and the support vector classifier class. And for evaluating our methods, we have imported these metrics, which are basically the performance criteria. So there is accuracy score, classification report, confusion matrix. So these are very, very useful tools. And we have divided our data set into two parts: features and classes. So X contains features. So we have 4 features that are indexed from 0 to 4. So this particular 4 will be excluded. So 0, 1, 2, and 3. So we have got our X, that is features, and we have got Y's, which are the class labels. And so we have split this in our training and test data sets. So we'll keep some of the data for training the system, and we'll keep some of the data for testing, that how well it has learned from the data. And in this case, we have trained this SVC, and then we predicted it on the test data, and then predicted the accuracy. So it was 93.33. Then we printed this confusion matrix, and this is our confusion matrix. that we have got it. So let's try to put it in heat map.
Hello. Okay, sir. पता नहीं सर लगा नेटवर्क प्रॉब्लम है। नेटवर्क प्रॉब्लम है। आवाज थोड़ी कट कट के आ रही है।
Hello. So we will left or stay here. Okay. 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 Sir. Okay. Okay. Sir.
Yes, am I audible?
Yes, sir.
Yes, can you hear me?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sorry for the connectivity issue. Am I audible?
Yes, sir.
Okay.
Yes.
Okay. So, after we have trained this model, we can take it to some web server, to some web application, and we can integrate it with some website so that we can, make intelligent predictions. So for that, we can use different frameworks which are available in Python. So there are two popular frameworks, Django and Flask. So has anyone worked with any of these frameworks for web application development?
No, sir, not
Flask
yet.
and Django.
No,
Okay.
sir.
So yeah. So what is the next agenda during this internship, that at least you learn how to train some machine learning model, how to integrate it with some web application, and how to deploy it in on some cloud platform. So there are different cloud platforms available like Amazon AWS, there is Google Cloud, and there is Heroku. So we'll be using Heroku Cloud to deploy our simple web application, and we'll be using a version controlling mechanism. So have you ever used Git and GitHub?
Yes, sir. We've used GitHub.
Yes, sir. GitHub.
Okay. So we'll be talking a little bit about how Git and GitHub, work, how you can kind of take different versions of your application to these repositories, and these are very very helpful. Once you enter industry, then you'll have to every day deal with these sort of technologies, because the projects are managed in that way only. So yeah, so let me share my screen. So for the next class, I advise you to refer these resources like Hello World of Flask, how to just write a very simple program to print Hello World in Flask. So we'll be talking about Flask, and better if you go through it. Yes. And read a little bit about Git commands for to push code to GitHub. So maybe you can find some tutorial where which will kind of introduce you that how to kind of push and pull data to and forth from your local system to some remote server or location such as GitHub. This is about GitHub. And the third one is that you should have some basic understanding of how to work in some IDE. So have you worked on some IDE in for Python, like a
Yes, sir.
Spider? Yes.
Yes, sir.
So which IDE have you used?
So Spider and Jupyter.
Yes. So I personally use this PyCharm, and there is a community edition for it. So you download this particular IDE, community edition of this PyCharm, and set it up, and it will make your tasks very easy, and you'll be able to manage. So install PyCharm community edition on your system. Right. And so we'll be creating them. We have trained this model, this machine learning model. We'll be creating some small web application around it. We'll be running this particular model behind our web application. We'll be just transferring this particular whatever we develop. We'll be transferring it to some Git repository, and then later on we'll be integrating our Git repo to a cloud platform called as Heroku. So there is Heroku Cloud, and we'll be deploying it on the cloud so that anyone can access a system. And I think it will be kind of good learning, provided that you have interest in learning. Right. So does it sound interesting?
Yes, sir.
Yes,
We'll be
sir.
using this Heroku Cloud, and there are many other options where you can deploy your Python based machine learning applications. This Heroku provide you some of the things where you can kind of utilize it without spending a penny, and you can utilize another website called as Python Anywhere. You can even deploy your web applications on this particular website as well. So have a look at these resources, make your accounts here, make an account on GitHub. GitHub getting started with. Maybe you can find some interesting tutorials on GitHub itself. We get to refer these. Okay. Read a little bit about GitHub, what it is, how to make a simple repo, what basically repo mean, what are the different terms associated with GitHub, what is pull request, what is push request, how people use GitHub for managing their projects, right? So after this, we'll be working on PyCharm. Let me show you that what PyCharm look like. So this is the community edition of PyCharm. Right, you can create any app here, and there are different projects, and every project runs in its own sort of virtual environment where you can track and you can install new packages, and those packages will not disturb the configurations of other packages. So we'll be talking about that, and we'll be installing Flask for one of our packages, and it will be pretty easy for doing that, right? And let me show you one simple Python uh, Flask based application. Right, so this is one alexithymia sort of predictor. So it's quite a complicated project, but it will just give you an idea that what type of projects you can develop using Flask, machine learning, deep learning. Right, so it has just started this Flask app, and it is running on local host. So it will open up on this, kind of page here. And at the back end, it has some small SQLite database, which is containing, the data. Uh, okay, so I forgot the password, like what type of registrations are there, but these passwords are available in this database.db file, and I'll have to kind of explore it. So there is DB browser app by which you can manage your SQLite database. Okay, so let me try opening it with DB browser. Right, so there are some simple, small tables here. So there is login table that contains, information about it. So this login table contains this particular email ID and this password. Ian Sherman password is test. So it will basically have two types of tests. One is ML-based trait assessment for mental health screening for one condition called as alexithymia. It will present some questions. You just need to quickly, send it. Let's keep some of these values. And move to the next. So here it will open the camera and it will present some of the visual cues to the person. And this is the live video. And it is recording my emotions while watching these visual cues. And after some time, it will stop it. It will record my, emotions. And then it will move to the, this particular part, get report. So there is one more sophisticated, module that it is under development, where you can get some, more sophisticated PDF reports. And for that, there is depression. There is another file, templates, report generator.html. Okay, it is not working. So this entire system has been developed, and there are many multiple, models which are kind of working behind it. So this is live video. And there is deep learning model that is running behind it to recognize the emotions. There is one machine learning model which was working at this particular page to have the prediction or assessment. And then there was combination of these two models to get some outcome, right? And you can deploy such, systems on the cloud, and there are different options for doing that. Yeah. So do you have any questions?
No, sir.
Okay. We'll continue this, this discussion, and maybe in the next class, we'll be talking about how to use Flask, how to integrate your machine learning models at the back end of your Flask, how to use GitHub, Git to manage different versions, and how to deploy your system on the cloud. Right?
Sir?
Yes.
Sir, I have a question.
Yes,
Sir,
please.
before the next class, what should we cover?
Sorry, could you please repeat, Amrish?
What do you expect us to cover before the next class, basically? That's what I'm asking.
Okay. So I have shared some
Yes,
links
sir.
with
Sir,
you.
what I was saying is, what do you expect us to cover by ourselves? Yes, sir. I have seen them.
Okay. So we'll be talking about Flask. One simple application of Flask. We'll be deploying some machine learning model on that. And so you are asking it from my point of view, like what I'm going to cover, or what you should cover from a student point of view.
Yes, sir. What we should cover before the next class?
Okay. So I would suggest that you just go through all these links, like have some basic idea what Flask is. If possible, download PyCharm and kind of integrate it, so that if you want to practice this along with me, it becomes easier. Right? So there will be installation of PyCharm, and referring to these tutorials on Flask, have a little bit of idea about Git and GitHub. So these three things you need to kind of just go through.
Okay, sir.
Okay. Any other question?
No, sir.
Okay, then thank you. Let's close this session at this point only. And once we complete it, once you get an idea how to create a simple Flask application, then you may pick up some data set. I'll suggest you some of the problems and may create your own system or own project around that. Right?
Yes, sir.
Thank you. Bye-bye. Take care.
Thank you, sir.
Yes, sir. मतलब कि I joined. I could join a bit late. So I was asking कि अब जब 1945 से पहले तक क्या क्या हुआ? 745 से पहले पहले तक क्या क्या हुआ था? एक समरी अगर मिल सकती है तो. ठीक है सर. ठीक है सर. थैंक यू. ओके सर. ओके.